Welcome in this video. In this video we're going to discuss the chapter motion, class 8 NCERT 9 class 9th NCERT chapter 8. So we will be only discussing the important point which are important for the perspective of your examination. So first we will describe the motion. Motion is simply like the change of object's position or orientation over the time relative to the reference point. Okay, it's simply like change in the position of an object or orientation. So like, let's talk about the motion in a straight line. It is a very simplest type of the motion. The motion in a straight line is something is going in a straight line without changing the direction. This is the motion in a straight line. The shortest distance measured from initial and final position of an object is a displacement. If suppose something is displaced from here to here, the shortest distance will be the displacement, and distance could be like longer than displacement. Distance is always equal and more than the displacement. So is the shortest from the initial to final position. The magnitude of displacement in the course of motion may be 0, but the corresponding distance covered is not 0. Suppose it initiated from here, it's circulated and it's end up also here. So the initial and final minimum distance is 0, and so that will be the displacement. So its displacement will be 0, and distance he has covered cannot be 0. So let's talk about the uniform motion and non-uniform motions. What are uniform motions? As an object covers equal distances in equal intervals of time, it is said to be a uniform motion. Like something is traveling like 15 km per hour for constant 3 hours. So that will be uniform motion for 3 hours continuously. And what is non-uniform? Non-uniform is the object covers unequal distances in equal intervals. So suppose in 1 hour it is covering a different distance. So suppose a 50 km, it is 100 km, it is 150 km. So it is covering a different distances in equal interval of time. They are called, this is non-uniform motion. Suppose a car is like, the car travels in non-uniform motion. Suppose like it is traveling at 40 km per hour, then some truck come, it slows the speed down, and it's again like 20 km, it's come down to 20 km, then the car accelerate again to 50 km per hour. So this is how, like, the speed is not constant. The motion is not constant. So this non-constant motion of an object is called non-uniform motion. The average speed of an object is obtaining by dividing the total distance traveled over the total time taken. So its average speed is equal to the sum of the total distance traveled, all the distance traveled upon the whole time taken. This will come the average distance. This is the average distance. We have an short derivation of it. If an object travels if an object travels 16 meter in 4 seconds and then another 62 seconds, what will the average speed? The average speed, total distance is 32 meter and total time is 6 meter. This is what the average speed. This is meter and second, so it can be divided into 5.33 meter per second. This will be the average speed, 5.33. Now let's talk about speed with direction. This is called velocity. Velocity is a speed of an object moving in a definite direction. It can be uniform or variable. It is calculated in the same way as we calculate the average speed. So the average velocity will be the initial and final velocity divided by the 2. This is the average velocity of the final and initial velocity. In case the velocity of an object changing at a uniform rate, if velocity is changing at a uniform rate, then the average velocity is given by the arithmetical mean. If it is changing in a uniform, only see this formula only applies for the if the velocity is changing at a uniform rate, only then the average velocity by this formula can be calculated by simple arithmetic mean, initial plus final divided by 2, average of first and last. If the velocity is variable, then different velocities should be add up, and number of different velocities measured, and that division will come into the average velocity. Same thing, the average speed and average velocity is calculated by the same way. The speed and velocity have a same unit, which is meter per second, same thing. Now average speed has a formula of total distance covered over total time, and the average velocity has a total displacement over the time. See, let's do this simple thing. Usha swims a 90 meter long pool. She covers 180 meter in 1 minute by swimming one end to the other and back to the same state. What is the average speed of this? So speed will be average speed and average velocity. See, speed will be distance upon time. The distance he traveled is 180. Average speed 180, and time, what time he has taken, centimeter long in 1 minute. In 1 minute is 60 seconds. This is what the 3 meter per second is its speed. Now velocity will be velocity. There is a displacement there. Since is go there, is again come back. So the its position does not changes. So the displacement will be 0, and time was taken a 3 minute. 1 minute. So it will become 0. So this velocity will be 0. Since velocity has a component of direction, so as its direction does not change, as displacement does not, position does not changes, displacement will be 0 and velocity will be 0, whereas the average speed will be there 3. Now discuss about the rate of change of velocity, which is called acceleration. During the uniform motion of an object along the straight line, the velocity remains constant. If there is a uniform motion of an object along with the straight line, the velocity remains constant. Suppose something is traveling 3 km per hour, so its velocity is same. However, in non-uniform motion, velocity varies. Suppose a car is traveling in non-uniform motion. Car always travels in a non-uniform motion, so its velocity always varies. Sometimes it will travel 10 km per hour, sometimes it will be 100 km, and and between any number. Acceleration, which is a measure of the rate of change of velocity of an object per unit time. So acceleration is a change in velocity and time taken. This is what the acceleration. If the velocity of an object changes from an initial value u to the final value v, then the acceleration will be this. This is in case of constant acceleration. If the velocity is changing constantly, then the acceleration can be calculated by initial value of u and final value of u divided by the time. This kind of motion is not accelerated motion. What is acceleration? Suppose a car is as rest and it has to reach a 10 km per hour. So it will start with the 1 km per hour, then 2 km per hour, then 3 km, and so on, 9 km per hour and 10 km per hour. So its speed is accelerating from 0 km per hour to 10 km per hour. This uniform acceleration, this uniform change in a velocity is called acceleration. Now the SI unit of acceleration is meter per second square. Why it's meter per second square? Because uh, velocity has already meter per second, and again this is this is velocity upon time, then the 1s again comes, then it goes up, they become s minus 2. Sorry, it will be like a meter per second, and it is second, it will, so this goes there, it will be meter square, meter per square, and this square goes up, it will be meter square minus 2. Increase or decrease by equal amount in equal interval of times, then acceleration of an object says to be uniform. So there could be two types of uniform, two types of acceleration. One is uniform acceleration. Suppose a car is accelerating at a uniform speed, at a uniform acceleration, and it can be non-uniform acceleration. It goes like this, then again slow down, then again fast down. Look at this line, it is very fast right now and it slows down again, it is fast. This is called non-uniform acceleration. The motion of a free falling body, free falls means someone is like falling under the force of gravity, is an example of uniformly accelerated motion. So we have a gravity like 9.8 meter per second. If object is fall down and we just remove the air resistance, so it will be accelerate for 9.8 meter per second. So suppose there is a ground, there is a earth, and there is a ball, and suppose there is a vacuum in it. So we will be neglecting the all the air resistance. So it is at the 0 speed per second. In 1 second it will reach as a 9.8 meter per second speed, and in again in second 2, in after 2 seconds it will reach at 2 into 9.8 meter per second, which will come around 18 or 19.6 meter per, and in again next 3 seconds it will be 3 into 9.8 meter per second. So it will be like, how much it will be, just add 9 more in it. So 9 more is 28, 9, 2, it will be this 9.8, 29.4 meter per second. So what is happening in the free fall, as there is no other force, restricting force like air pressure, is vacuum is there, due to the gravitational force, constant gravitational force, an object is accelerating at the speed of 9.8 meter per second square, and this constantly its speed is constantly increasing in every second. So this constant acceleration is called uniform acceleration. And car moving with a non-uniform acceleration, because car has a brakes and it has to apply the brakes most of the time to control the speed. So this is called non-uniform acceleration. And graphical representation of motion, like discuss about the distance time graph, change in position of an object with the time. And this is the time and this is the distance, it is going this way. So like time is changing and the gap is same here, also the gap is same here. That means the time is constantly changing and also the distance is constantly changing, and they are in proportionate, the line is straight. This shows the speed is, the time is directly proportional to distance. As the time is increasing, the distance is also increasing. So this will be called uniform speed. The distant time graph an object with a uniform speed. For a uniform speed, the graph or distance travel against time is a straight line. We can use a distance time graph to determine the speed of an object. And how we can, suppose this is a triangle, and this is a triangle. AC denotes the time interval, and BC, which is BC denotes the distance. Suppose this is a point A, this is a point B, and object travels from the 30 kilometer. Object is here 30 kilometer. It goes from 30 kilometer to 40 kilometer, and it takes time. So it can be like, this is a triangle formula, so we have to apply a formula. So this will be the, it covers the distance of S2 minus S1. So distance will be like this minus this, which is a 10, and the time will be this. Suppose this is a 60 and this is 40, so 20. So this is how we can distance upon speed we can calculate, distance upon time we can calculate as speed. This is how, by this triangle, this speed time distance time graph, we can also calculate the speed of an object. Now there is again one more distance time graph for a car moving in a non-uniform motion. So as the time is there, it is goes with this, and this type of graph shows motion is accelerating. As the time goes, the distance is like going very fast, it is traveling too fast, and this types of graph shows like its speeds is increasing. In every patch of the time we can see the distance is increasing. See, you can look at this, distance is increasing. So distance upon time, distance is increasing, and overall the speed will be increased, and this increasing will be the accelerating speed. Now velocity and time graph. So velocity and time graph in a uniform motion is a uniform, then the speed will be same. Suppose it is a 40 km per hour. This is the speed at 40 km per hour. So speed will be the same, and the graph will be this from time 1 to time 4. This will be the time taken, only time will be changed, but the speed will remain the constant. This is how a rectangular type of graph will be formed in case of velocity time graph, in case of uniform motion. We know that the product of velocity and time gives a displacement. Definitely product of velocity and time gives a displacement of an object moving in a uniform direction. We have already discussed velocity is a displacement upon time. That definitely the velocity and time gives a displacement. So t goes here. So displacement will be velocity into time. Uniformly accelerated motion by plotting its velocity time graph. We can also calculate. We can study about the uniformly accelerated motion by plotting velocity time graph. Driver records its velocity after. This is, I don't think what is. Velocity changes by equal amount in equal interval of time. So thus all the uniformly accelerated motion, the velocity time graph is a straight line. Uniform acceleration in all cases, the velocity time graph will be. Earlier we studied a similar graph which is for the distance time graph, in which the speed is constant. Now we are discussing the velocity time graph, when the velocity is this straight line, and this shows the acceleration is a uniform. The velocity time graph of car, uniform acceleration. If a car would have been moving with a uniform velocity, the distance traveled by it would be represented by the area ABCD. So this is the area ABCD, A, B, C, D. Area of ABCD will be the of total area of uh, this since the magnitude of the velocity of a car is changing due to acceleration, the distance s traveled by a car will be given by the distance s traveled by the car. The distance can be calculated by calculating the area of ABCDDE. By calculating this area we can find a distance, and s equal to we calculated this, the rectangle area plus the triangle area, this comes to this, and this is how we have a formula which we will discuss in higher classes, which is s equal to ut plus half at square. This is how the formula comes. This is called laws of motions. Velocity time graph of an object in a non-uniform accelerated motion. Acceleration is going down and up and up. This is velocity and time graph will be in case of non-uniform acceleration. In case of acceleration, there will be straight graph. Now equations of motion by graphical methods. So we just studied the different graphs of distance and time and velocity and time. On the basis of this, we have deduced some formulas for uniform acceleration and uniform motion. When an object moves along the straight line with a uniform acceleration, it is possible to relate its velocity, acceleration during the motion, and distance covered by it in a certain time interval by set of equations known as equation of motion. These are the equation, and which is only applicable in the uniform motion. S equal to ut plus half at square, which comes from this graph, and u plus at plus half, v equal to u plus at. We studied this from 8.5. We will further, in 11th class, we will study how this equation came, derivation of this equation. Second is s equal to ut plus half at square. This is from 8.3, velocity time graph, and this is 2as equal to u square minus v square minus u square. These are actually s is a distance, and v is a final velocity, u is a initial velocity, and a is a acceleration, and t is a time. In 11th class, we will discuss these laws of motion further, and also we'll know how these equations came from these graphical methods, and we will also derive them. These three equations can be derived by graphical methods. Oh, actually, these are the derivation. This is for the first one, and this is for the second one, and this is from the third one. These are derived from the graphical method. This is the graph. So it's mathematics here. So we will be only like discussing the concept only. We will not go into the derivation. Now talks about the uniform circular motion. When the velocity of an object changes, we say the object is accelerating. Definitely it will accelerate, but the motion of an athlete moving in a circular path is therefore an example of accelerated motion. Suppose why the circular motion is accelerated motion. because although its velocity, suppose it is like something, the car is moving circular at 50 kilometer per hour, 50 kilometer per hour, and its speed is not changing, its speed is uniform, but a distance is changing, distance is changing. So this is why this is accelerating objects, it needs external forces. We know that the circumference of a circle of a radius r is given by 2πr. If an athlete takes a t second to go once around the circle path of a radius r, the speed v is given by this. The speed v will be 2πr, which is the circumference, and the time taken by it. This is the simply the distance. 2πr is a simple distance, and this is the time taken. This is come to the speed. Uniform circular motion. When an object moves in a circular path with a uniform speed, it is called uniform circular motion. So in a circular motion, although the speed can be uniform, as the direction is changing, the motion will be accelerated motion. We have almost finished the chapter. Let's revise it quickly. The motion is a change in the position. It can be described in terms of distance moved or the displacement. The motion of an object could be a uniform and non-uniform depending on whether its velocity is constant or changing. And acceleration of an object is a change in velocity per unit time. We have discussed this. Motion of an object moving in a uniform acceleration can be described with the help of following equation, namely in a uniform acceleration, this is only for the uniform acceleration, u is the initial velocity and which moves with the uniform acceleration. A is the acceleration, t is the time, v is the final velocity, and t is the time taken by it. If an object moves in a circular path with a uniform speed, its motion is called uniform circular motion. Thank you for watching this video.